Okay, now we're going to look at synthetic division, which is another form of dividing polynomials. You're going to view this segment and then you have a few more problems to work out. So synthetic division allows us to divide in a simpler way. It simplifies the process, and there are a few key steps that you need to keep in mind. Number one is that we're going to use coefficients, and you need to account for every degree. So if you have x to the fourth, you need to make sure that you have a space occupied by the coefficient for x to the fourth, x to the third, x squared, x to the first, and you can do that also by adding in the zeros like we did in long division. But you must have them all accounted for. You're going to use only the coefficients. We're going to omit writing down the variables and the exponents, so that's going to make it a little bit easier to write out. We will take the reverse, we'll reverse the sign on factors. If you're given a factor, x minus 2, then you would begin your division process by using 2. If you are asked to find the value when x is 12, then you would just use 12. And we'll go over the difference of these as we go along. But you're going to reverse the sign on your factor, and you're going to use, again, just the constant. You're going to be omitting. And we will also add in this process. In long division, we subtract. We use variables, and we use constants and exponents. Here, we simply will just use the coefficients, and we're going to be adding. So let's look how this works. So the example is use synthetic division to find out if x plus 2 is a factor of x cubed minus 14x squared plus 51x minus 54. So let's do that. So we're going to set it up. We know that x plus 2 is equal to 0, and we can find that x is equal to negative 2. Remember that we are seeding this with just the constant. We're not using the variables. We're going to set it up on the outside. See how I drew the little box? You can think of this as hiding your divisor, but your divisor goes in that box. And then what we're going to do now is list all of the coefficients as they go across. We check and we make sure that every power is accounted for. We have 3, 2, 1, and then 0, so we know we have what we need, and we just set it up. These are really easy to set up. So you see now I have them just listed in a straight line. I skip a space, and then I put another line underneath it. And what we're going to do is we're actually going to seed this process with our first coefficient. So we bring the 1 down, and then we're going to multiply it by the negative 2, and then we put whatever answer we get right here underneath the next coefficient that we listed. Now we add, get negative 16, and we continue the process until we get to the very end, where we find out that our answer is negative 220. What this tells us is that x plus 2 is not a factor. This would have to equal 0 for x plus 2 to be a factor. So it is not a factor of the expression that they gave us. Okay. So let's go on. So remember how we used to find p of x when x equaled a or a specific variable? We would have to substitute it into the function and then simplify it. Well, what we find is that we can also use synthetic division for that. It makes it a much easier, cleaner process because you're not worrying quite as much about your signs and the different operations. So let's look. What is p of 3 for x to the 5th minus 2x cubed minus x squared minus 2? We're going to write it out. We have to account for all of our exponents. So you see that I have a 0 here and a 0 at the end. So we seed it with 1, and then we go back through 3 times 1 is 3, bring it down. 3 times 3 is 9, 9 minus 2 is 7, bring it down. Put it over underneath the next one, and then we finish. And we find again that this would not be a factor, but that the value for P of 3 is 182. So this is the same as if you had plugged in 3 in the expression and then solved it. You just use a synthetic division and find that P of 3 is equal to 182. A few things to remember. When you're using synthetic division, you always need to account for each exponent level. Put them in descending order and make sure they go down by 1. You're going to be using only the coefficients. You're not using the variables, and you're not using the exponents. And then you need to remember, given a factor, you're going to use the opposite sign. And you add. Synthetic division is best used for factors and finding specific values of a variable. There are a couple more examples on the handout that you have, and then there's some in your book. So I want you to be sure, if you're not sure how this process is working, to review the video and then complete the odd number problems so that we can go over them when you come into class on Monday.